Hi, so I would like to introduce one of the papers I read. So this one is about what kinds of factors we need to taking care of while building our HRI system. So this specific reading, is mostly about safety, the interaction between when there is collaboration between human and robot. There's different kinds of interaction, and how would what kinds of HRI could let like the human feel like trust the robot and can be more safe for human. So let's go with the first part, the introduction. So basically, in the introduction, the author basically introduced several content that is like going to introduce later. One of these is like safety. So when robots and people work together, making sure everyone is safe, which is very important. And the author also talks about how people and robot can communicate or interact. This can be done through many ways, talking, using hand gesture recognition, or even like moving your fingers to something like that. And this paper also talks about how important it is for robot in the factories to be reliable and efficient. So let's go into the context of different project this research paper used. So basically, in this paper, the author introduced the project called the 4x3 project. So that is the 4x3 project is basically a modular industrial robotic solution for safe and efficient HRI collaboration in specifically manufacturing area. So in this project, they basically developed a modular industrial robotic solution that includes series elastic actuator, control unit, additional auxiliary module. These components are integrated into robot operating system, which is ROS, based control architecture. There are also many safety measures implemented in this in order to behave safely around human. So operator can monitor force and torque, and external monitoring system uses projection and vision system to keep track of robots relatively distance to worker, eliminating sharp edges. You can see from this picture that it's basically like different it's a different system for the safety part. And they also trying to make it easier to use. So many interaction mechanisms are implemented, like voice, gesture, in order to facilitate robot programming and control. So yeah, and they basically have different approaches for safe HRI. Like different approaches for safe human robot interaction can be classified as two main approaches for ensuring safety in HRC are discussed. They call post collision and the pre collision. So the post collision is basically focused on like minimizing damage when the collision has occurred. So it's basically like it's like mostly commercial stuff. It's just like when a collision like definitely will happen, they need to comes up a way that can make the damage to minimize the damage. So it's basically like, let's see this case. So use this approach. So like power and force limiting, series elastic actuator, protective skin. So it's kind of like if this stuff can cause damage, why don't we make this like having less sharper edges, having softer skin or like softer mechanical parts, so that when the collision happens, they can have relatively lesser damage. And this is basically the post collision strategy. And there is also, on the contrary, the pre collision strategy. So basically, by detecting them in advance. So it's trying to like, the first one is more like when it will definitely happen, what should we do to make the damage, to minimize the damage. The second one, the pre collision strategy, is basically the one that is like make use all they can to prevent the collision. For example, messes that given that I'm over. So turning these robots into human-safe platforms is a great interest. Various sensor technology have been explored for the purpose. Yeah. So in this paper, the author also mentioned various technologies for like sensing human presence and movement. So it's like when the people are moving, robots need to be more careful about the human or careful about the robot's movement, such as like using in this paper the author basically mentioned like the LED marks or like motion capture, so that when they're using LED to like make people notice that there is a robot, or like when it detect any people coming approaching, it will slow down, something like that. It also mentioned research on factors that influence trust in human robot interaction, especially in high risk situations like military applications, something like that. So it's basically about trust. So it's kind of interesting. So basically, before the experiments begins, the author tries to analyzing the factors that could affect the trustness in the HRI system. So let's see, performance of robots. So this one is kind of interesting. So it's found that the performance of robot has the most significant impact on trust. If the robots performs well, people are more likely to trust it. It's like in real life. What if your teammate is like super like ambitious and go-getter, so you will more likely trust your teammate. And if your teammate is like, I don't want to do this, I don't want to do that, something like that, you will unlikely to trust it, just like real humans. So the second one is like environmental factors. So the same study from the first, the performance one, they also found that environmental condition has a little bit influence on the trust. For example, like the complexity of the task or the settings may also affect how much a human can trust the robot. For example, if you're saying like, hey, let's play dodgeball, this is kind of like more easier to trust. If you're saying like, oh, let's get some lava from a volcano, so it's that in that case, it's more like harder for a human to trust robots, since the environment is already very dangerous. And there are also human factors. So interestingly, but I'm not very surprised that human related factors like your mood or like preconceived notion show a little bit evidence of affecting trust. Like you're just getting betrayed by someone. This may seem ridiculous, but this is very realistic. Like if you are very unhappy, if you are kind of pessimistic about anything, or you're being really depressive, you're unlikely to trust. So something like that. And the last one is the type, size, proximity of the robot. So this one is easier to understand. So the physical characteristic of the robot, like the type, size, and how close it is to the human, can also influence trust. Like if you are saying like, oh, I made a machine ladybug, you're like, oh, so cute, ladybug. So it's like very easy to trust because it can do no harm to you. It's a ladybug. But if you're saying, oh, I made a Megatron from freaking Transformer Megatron, you'll be like, oh shit, it's Megatron. So you'll be like, it's come like harder for me to trust. This is like that. And other than these factors I mentioned here, the author mentioned in this paper, they can also be influenced. The trust can also be influenced by many other unexpected factors, including like some factors within the robotic system itself, like the operational environment, the characteristic of the human team members that designed the HRI system is something like that. But it's pretty minor, not very minor. Okay, focus. So this experiment, the author proposed a set of experiments, and the focus of the experiment is basically about safety and interaction. So it's basically safety is about like how like worker will think about the safety level when the worker is working near a industrial level robot that doesn't have physical barriers. If it has physical barriers, it will be like everything is very calm and something like that. But if it doesn't have physical barriers, really like a challenge for the people who design the system. So specifically, the experiments aim to gauge workers' perceptions of the safety measures proposed and implemented by this project, 4x3 project. So they're trying to see the safety. They're trying to focus on the safety and the interaction. Like the interaction is very easy to understand. It's basically about using different ways. So like what kinds of interaction ways can affect how people feel about the currently, whether they are safe or not. So yeah, this experiment. So basically, what they did in this experiment is like they I'll just skip this part. So basically what they are trying to do is they made a tons of, what is it called, certain spots. They made like they will ask people to work with a robot to complete a job, like putting screws in some spots, like these spots. So after doing the task, people will fill out the survey. This is basically questionnaire based research. They fill out the survey to share how safe and comfortable they felt working with the robot. And so the study, they found that it's kind of interesting, that it's kind of worth mentioning that there are also like similar experiments before. It's like performed by MIT, but they use in the MIT team, they use 20 people from their own university. So it's the MIT staff, students, like that kind of people. So it's kind of related, but this is like the new experiment they did. They did completely different. They used people who were just visitors, because they had a couple of different fairs, and they have like no connection to the researcher. So in this way, they hope they can get like a more unbiased opinion, which I think that is very important, because personally I did a IQP. That is like very important to let the participant to know nothing about the experiment, so that they will have less biased opinions, so that it will heavily affect the result of the questionnaire. Especially this is heavily based on questionnaire to get the feedback from the participant. Okay, so they did this experiment in two different places. One is called Technishow. This is like basically the largest and most important trade show in the field of industrial production technology. The second one is called I'm just gonna give it up, the BIEMH. So this is like a biannual fair. It's the one of the most important industrial fair in Spain. It's devoted for machine tool, this all kind of industrial related stuff. Okay, so the first study. So they did the first study. By the way, I have to mention that these two studies happen in, they have different interaction way. I'm going to mention this later. So in the first study, happened in Technishow, they're using a universal robot, which is like you can use it in any other way, all the other ways. So it's not just for the experiment. So they use many different way to interaction ways. So using pointing gesture. Pointing gesture in this place is like you point it in this way, as you can see from the picture. Basically, you point, participant will point, say, hey, can you pick up this? The pointing at a cube. So the robot arm will try to pick it up. This is the pointing gesture. And the safety monitoring. So this one is kind of interesting. So what they did is they will ask the participant to move like super close to the robot to see based on the feedback or the reaction of the robot, to see how the participant will feel. So they found out that, so basically if the people get too close to the robot itself will just stop moving. So this is the one of the way. And there are also some manual guidance. So basically, they allow the participant to move the robot arm to a location. For example, you can just, instead of some robot that you cannot touch it at all, personally, I would think that kind of robot that does not allow people to touch him, I feel like these kind of robot can give people like unfamiliarity. Like you will feel very unfamiliar about the robot. This is like kind of mysterious vibe. At least I would feel like that. So they're doing like, participant could move the robot's arm. You can even move the robot arm and say, hey, this cube, and then move the arm to some place above the cube, something like that. Collision. Oh my god, I love this part, collision. So this part is that they will basically push the participant towards the robot to see like what will happen to what will happen what to let participant to see the feedback of the robot. So the basic robot, the result is they will generally like collide with the participant's arm to test. They will like push it, and the robots will be like, "Oh, I'll stop," something like that. So this is the first study. This is second study. This is like a little bit different. So the second study is like had less interaction measures. So they use this robot. It's kind of similar, but it's like they had different. So this one is like they kind of similar to the first one, that they have something robot arm to pick something up. Then but this one is like moving stuff into a bin. You can see from the picture the small blue bin. And they also can test it, the tapping and pointing. So basically, instead is the first one is like if you move really close to the robot arm, it will stop. This one is like if you want the robot arm to stop, then you just like tap it. You just tap the robot arm. It's like clink clink, and then stop it, and then it will stop. And then you can point at the objects like clink clink stop. Can you pick that up? And then point to specific object, and they will pick up. So after this experiment, they also collected the demographic data. So I don't think this is like super related, but I will explain later why personally I think this is really interesting. So 30% had more than 10 years of experience in various roles like machine operators. So 13% basically expert of the expert. 8% has between 6 to 10 years of experience with robot, which is basically expert, just not that kind of expert. 37% has between 1 to 5 years of experience. So they are very familiar with the robotics, the HRI system. What is interesting to me, I made that into a red font. So what is very interesting to me is like the remaining 48% never directly worked with robots before. I think that is very interesting because it's important to have, because if you previously work in the related field or area, you will feel more likely to get you were more likely to trust robot because you've been working with robot for many years and many time before. So you will naturally feel more confident when you are having collaboration with robots. And so, but it's kind of interesting that they use lots of, basically most people, they are participating in this project, they had never worked with robot before. This is really like a test for the HRI designer. So these kind of people, so I would say it's basically the hardest to gain, to have trust with robot, because if you are never so the robot stuff is like completely new to you and you had no previous knowledge. So how safe do you feel this robot is to you is based on the current movement, the safety measure and mechanism. So I think this is very important. Okay, so let's check the results of this study. So as we can see, so this is a graph that the lighter color is for study 1 and the darker colors for study 2. And from this, the y-axis, the top half is for the best rating. So if the rating is higher, then the dot will go higher, and the rating is much worse, then it's go a bit lower. So from the left to right is for naturalness, reliability, usefulness, difficulty to perform, and response time. So basically, as we can see from the graph, the most obvious thing we can notice is that the study 2 basically shows some definitely significant improvement in the user experience compared to study 1, especially in the perceived response time, so which is this one. As you can see, the study 2, the darker color, is way much like in the upper area comparing to the study one. Study two is better than study one. So the author like do think this is maybe due to the LED light, that because the study two has a LED light that installed on the robot arm. So when to indicate that when the robot was waiting for the gestures, I personally I think this is more friendly or like more into intuitive way to show that is currently waiting. I think this is a very good feedback. So that is why it got the most satisfied in the response time. So the other stuff is like here is like kind of close except the response time. So I think yeah, this is the chart. So here comes the study one. So study one, just to remind you, the study one is for the hand guiding one. The study one is that the one that you can move the robot arm to around that one. So they ask, so the author team, they asked the participant to answer whether how's the effort is the participant use, the usefulness, and the difficult to perform. So as you can see, the people are generally positive about guiding the robot arm manually. As you can see, this is the standard deviation is here, this square. As you can see, this is definitely like in the upper parts, and although some find the effort, as we can see, it's pretty obvious that the effort part needed is kind of like is the limitation of the hand guiding system. So let's go to study two. So the study two is basically the one that the participant can tap on the robot's arm to let it stop, and then pointing to the object. So as we can see, the naturalness, reliability, usefulness, difficulty to perform. So basically this was generally well received. So user tap on robot arm lightly to resume its activity. So basically from the report showing that 8% of the participants find it kind of unnatural. So it's like here, this part. And but because it doesn't require additional sensor, its interaction worth kind of considering, because it need less sensor, is definitely has less cost. So that's why me and Arthur will think this is worth concern, because the low cost and the easiness to imply in the future. So after these two analysis, the author also comes out with like asking participants about the safety, this is basically the most important factor of this experiment. So as we can see, people felt safe working with the robot, which used like a vision system to stop moving if someone came too close. As you can see, this number was pretty good. This very close to the best rating. Basically, this very good review. Everything is good. Everything is like on the very top bottom side. So the author explained that the study 2 has some on the bottom is because it got too many, like the base numbers too high. There are tons of people attending. People are all workers and owner of all kinds of industry. So that is why. But some workers had concern that if we introduce these robots, it might reduce the numbers of jobs available. That is like kind of a serious concern. We don't want the manufacturing industrial field to be like completely like human free. That is like not very optimistic about the jobs. So they also ask the workers' opinion. So basically they will have most of them, as we can see, we can first notice this part is it have tons of workers have very negative opinion about whether it will affect numbers of jobs. So many participants felt that the introduction of robots in the workplace would reduce the number of jobs. But the others are mostly very positive. They most agree that the robots would improve the productivity, and the quality of production and the working condition and such. So everyone It's kind of ironic that most of the people think this is basically a perfect solution, basically a very good solution, but the only bad thing about it is that it may, it's not may, it will significantly reduce the number of jobs. That is something that the developer also need to consider about it. And this is the questionnaire about the key requirement for success. After each study, they give out the questionnaire to ask people whether it's safety, reusability, flexibility, adaptability, efficiency, and other stuff. So safety was considered the most important factor for the successful introduction for the cobots. This is what they call the cobots. Cobots is I think it's the one in study one, and followed by second one is usability, and then flexible, and then efficiency. Seems like safety is basically the most is in the most priority for the concern. So basically, for the conclusion, like, and 97 of the participants from the first study felt that human robot collaboration is possible and would accept working in this manner in the future. So overall, they have a positive perception of safety and trust regarding the collaborative robots, and that is a good thing. But in the gesture and hand guiding interaction, which is the one in study 2, the participant also rated the gesture based and hand guiding interaction very positive. So and seeing them as useful for the future work study, but there's some limitation for this study. So the author feel like the limitation of that is like the currently the work mode for the robot arm is too naive. It's too simple. It's just simply picking up blocks based on the human gesture, human operation. And the author feel like it needs to be revised in a more realistic and long-term environment so that it can mimic the actual manufacture process, so they can more better blend in with the future workflow in the actual industrial environment. But and personally, I think because this study is basically about the factors that will affect the trustness for human to trust a robot, I think it really delivers the point that it's mostly based on the gesture, based on the how the interact way, how will human interact with the robot, and that's pretty much well delivered. But I have a point that is basically it's not very in the point that it's not very relative about the factors in the human factors of the human trustness, but this mostly about the concern. So many reader and many people after they check this paper, they will feel like it's kind of like pessimistic about whether robot will replace human labor and causing human in like losing their job. So I'm not very surprised that workers are not worry about this efficient, not very worry about safety, but it's about to replace worker in the future. That reminds me of the spinning jenny, the machine that is used to making threads. So many workers, by the time the spinning jenny is invented, many workers even trying to kill the person who invented this machine because they thought that the machine would just take over human labor, so they have to start. But they are not wrong about that. But the spinning jenny, from the long history, the spinning jenny is one of the most important, one of the most crucial elements in push the process of industrialization. So personally, I think the right now the technology is very advanced. I'm not worried about whether this will work or not, whether this is efficient or not. I think these are the stuff that is really easy to be solved. But the problem I am mostly worried about is that I think people need to come up with a way that how to let the workflow get used to the addition of robots getting into the workflow, because right now, uh like just like the spinning jenny case, the people are not they are not very wrong. Currently there are no people like using the spinning machine anymore to make threads. They are replaced by the machine. This is correct, uh but we need to consider like a more friendly human and robot interact scenario. It's like currently I cannot think of any way that is to solve this, but I think this is, to me, this is more important than considering the efficiency of the robot, because the technology is happening, everything is happening so fast that these problems just can solve in the blink. That won't be a problem at all. But because the technology is advanced enough, this is something that we need to comes up with our schedule. It's about how human can get used to the participation of the robot into the workflow.